So here today I will be discussing, or not today, means we will be discussing the dimensions of physical quantities. Earlier we discussed, like there was seven fundamental quantities, and there was two supplementary quantities. Our supplementary quantities was plane angle and solid angle. For plane angle, the unit was radian, and for solid angle, it was steradian. But these two supplementary quantities are dimensionless. They don't have any dimension. Whereas the seven physical quantities, length, the unit of this was meter, but we will show the dimension. How we will be showing the dimension? Like these are the braces, and this will be denoted by L. The dimension of this length is denoted by L. Okay. Similarly, for mass, it will be denoted by M. And for time, like we will denote it like this. Actually, these are the dimensions. These are dimensions. So, like mass, time, not temperature. For temperature, we denote it like this, K. For electric current, it's ampere, so we denote it like this, A. Here temperature, it's Kelvin, so it's K. Luminous intensity, so like Cadilla is the unit of this luminous intensity, so we'll denote it like this. These are the dimensions. You can remember that these are dimensions. And there is an other amount of substance, that is mole, so we make it like this, mole. So this is how we show the dimensions of these seven fundamental quantities, like current, luminous intensity, amount of substance, length, mass, and time. Okay. We can also calculate the dimensional formula, like these are the dimensions, so we can also calculate the dimensional formula, like suppose for force. Now we we are already aware of the force formula, that is force is equal to mass into acceleration. This is mass and this is acceleration. So like here, their mass will be like this m. We will write it like this m. For acceleration, it is the unit of acceleration is meter per second square. So for meter length, it's L. We will write it like this. Okay, and for second upon second, and this is L, and for second it is time. For second it's time. So it will be t square. So the dimensional formula will be m l. This is t square, so we can make it like this: t raised to the power minus 2. So this will be the dimensional formula of this force. I am repeating it, like for force we have this is mass into acceleration. Like we are already aware of this formula, force is equal to mass into acceleration. For mass, what we have here, for mass, this is the dimension of this mass. So we make it like here m. For acceleration, like the unit of acceleration is meter per second square. So what this meter? This meter is length L. This meter is length L. So we wrote it like this as a L. Okay. And this is second square. This is second. Second is a part of time. Like second is a part of time. So it will be upon L upon T square. So when we rearrange this thing, it will be M L T raised to the power minus 2, and this is the dimensional formula of force. This is dimensional formula of force. Okay.